Hey everyone and welcome. If you're gearing up for your Class 10 board exams, you're in the right place. This is your super fast revision of Chapter 2, Acids, Bases, and Salts. We're going to hit all the must-know concepts, reactions, and applications. Everything you need to nail this chapter. Okay, let's start with something we've all felt. You know that feeling after a big, spicy meal when you get that awful acidity? So what do? Would you grab some lemon juice? Maybe vinegar, or a solution of baking soda? The answer is all about chemistry, and trust me, by the end of this, you'll know exactly which one works and why. So here's what we're covering. First, what are acids and bases? Then we'll dive into the key chemical reactions. After that, we'll uncover the secret of ions, figure out how to measure strength with the pH scale, and finally, look at some common salts we see all the time. Let's do this. All right, first up, how in the world do we even tell these things apart? Well, it all starts with a few basic identifiers. Okay, you're definitely going to see this on your exam, so let's nail this down. Acids, they taste sour. Think lemons. Bases, they're bitter and feel kind of slippery like soap. Now, for the litmus test, here's a simple trick. Acids turn blue litmus red, bases do the opposite. They turn red litmus blue. Easy, right? Now, obviously, we are not going around tasting chemicals in the lab. No way. So how do we test them safely? We use something called an indicator. These are just substances that change color or even smell to tell us if something is acidic or basic. Some are natural, like turmeric from your kitchen, and some are synthetic, like phenolphthalein. There are even ones like onion that change their odor. Pretty cool. Okay, so we can spot them, but now for the really important part, especially for your exams. What happens when they mix? This is where the real action is. Pay close attention here, because this is a classic. When an acid reacts with a metal, like zinc, you'll see fizzing and bubbles. But what gas is that? To find out, we do the pop test. You just collect some of that gas and bring a burning candle or splint to it. If you hear a loud pop, congratulations, that's hydrogen gas. You absolutely need to remember this one for your exams.
So the general rule is simple. An acid plus a metal gives you a salt and hydrogen gas. Basically, the metal is strong enough to push the hydrogen out of the acid and take its place. That's a displacement reaction, and it's a super important concept.
But what about when an acid and a base meet? Well, they neutralize each other. It's like they cancel each other out. The result? You get a salt and plain old water. And hey, remember that stomach ache? This is exactly what's happening when you take an antacid. The base in the antacid neutralizes the extra acid in your stomach. Problem solved. But why do they behave this way? What makes an acid an acid? The secret isn't the whole molecule. It's about tiny charged particles they release in water. We call them ions. Here it is, the one thing all acids have in common. When you dissolve them in water, they release hydrogen ions. H+ ions. This little guy is the reason for everything. The sour taste, the reaction with metals, all of it. So when you think acid, you should immediately think H+ ions. And you guessed it, bases have their own special ion. When they're in water, they release hydroxide ions, OH- ions. This is what gives them that bitter taste and soapy feel. So it's simple. Acids give H+, bases give OH-. And here's something really cool about these ions. Because they're charged and free to move around in the water, solutions of acids and bases can actually conduct electricity. That's why the bulb lights up. But if you try this with something like sugar water, nothing. Sugar doesn't produce ions, so there's nothing to carry the current. Okay, so if all acids make H+ ions, are they all the same strength? Absolutely not. And that's where the pH scale comes in. It's how we measure just how acidic or basic something is. Think of the pH scale as just a ruler for measuring acid strength. It goes from 0 to 14. The P in pH actually stands for potens, which is German for power. So we're literally measuring the power of hydrogen. This is super important. Anything with a pH less than 7 is acidic. And here's the trick. The lower the number, the stronger the acid. So a pH of 1 is way more acidic and dangerous than a pH of 6. Right in the middle, at exactly 7, we have neutral. The perfect example is pure water. and anything above 7 is basic or alkaline. For bases, the scale works the other way. The higher the number, the stronger the base. So something with a pH of 14 is a very, very strong base. And believe me, pH is everywhere. The acid in your stomach is around pH 2. Your teeth start to decay when the pH in your mouth drops below 5.5. That's why toothpaste is basic to neutralize it. Farmers even have to check the pH of their soil to make sure crops can grow. It's incredibly important. All right, last section. We know that salts are made when acids and bases neutralize each other. But when we say salts, we're not just talking about table salt. Let's look at a few really important ones. First up, baking soda. Its chemical name is sodium hydrogen carbonate. It's a mild base, which is why it's a great antacid for an upset stomach. It's also what makes cakes fluffy. When it gets hot, it releases carbon dioxide gas, and those bubbles make the cake rise. Next, we have washing soda, or sodium carbonate. This one's used in making glass, soap, and paper. At home, it's a great cleaning agent, and it's also used to soften hard water, which helps your soap and detergent work much better. And finally, plaster of Paris. This is a pretty amazing one. It starts as a powder, but when you mix it with water, it sets into a hard, solid mass. Sound familiar? Yep, it's what doctors use to make casts for broken bones, holding them perfectly still so they can heal. So there you have it, a super quick run-through of the whole chapter. But before we go, here's a question to really get you thinking. The kind of thing that could show up as a high-level question on your exam. We know a strong acid and a strong base make a neutral salt with a pH of 7. But what if a strong acid reacts with a weak base? Who do you think wins that fight? What will the final pH be? Give that some thought. Keep going over these basics, and you're going to do great. Good luck!